Hey, what is up, you guys? This is Justin, and before I do get started, I wanted to thank all you guys for making me a part of your day. So, we're going to do another quick lesson. Most of these lessons are off the top of my head. I don't really... So sometimes I plan on making it short, and just the teacher side takes over, and we'll go from here. So, no timer. We'll start it right now. This is going to be a geometry lesson, so it's going to be over the Pythagorean Theorem, which probably will take longer than 10 minutes, but I'm going to try to really do this in underneath 10 minutes. So let's go ahead and get started for today. So we'll go rudimentary. Actually, I'm not even going to put that because I don't even know if I can spell rudimentary correctly, but we'll just put Pythagorean Theorem, okay? Now, one of the interesting things about the Pythagorean Theorem, actually the interesting about the distance formula that you guys learned in like pre-algebra, is it's derived from the Pythagorean Theorem. So there's a whole story behind this, but we're just going to go ahead and get the basics of what we're going to do today. So you're going to have a squared plus b squared is equal to c squared. All right. So with the Pythagorean Theorem in math, okay, here's another thing too. In math, when you have lowercase, I usually write in all caps, okay? But when you have formulas, the lowercase letters, I took a history of math class. If I remember correctly, lowercase letters are usually parts of like a shape, okay? When there's the big letters, it usually means like a formula, like a surface area, big area, so on, area of the base, and so on. So you have to use lowercase letters for this. I don't like using lowercase letters, but there's some things in math that you just have to do that you don't like, all right? So here's what we're going to do. The only real important part of this formula is going to be the c, which is what we call the hypotenuse, okay? Now the hypotenuse actually shares a few characteristics. These two are called legs. We don't really care about those. Even though you need legs in real life, we don't really care about those in the Pythagorean Theorem, okay? So one thing about the hypotenuse, it has a few characteristics, and I should have actually thought about this before making this video. The first one, it's opposite side of 90-degree angle, okay? And actually, I'm going to go backwards. I should have said this before, okay? And it's also always longest side, okay? So those are the two things that you have right there. One thing that I should have told you before, the only time you use the Pythagorean Theorem is if you're trying to figure out if it's a right triangle, okay? So use when trying to figure out right triangle. That's kind of a terrible sentence. I'm not an English teacher, forgive me. But one of the common things is that when you guys get into law of sines and law of cosines, you can't use the Pythagorean Theorem because it's not a right triangle, okay? But the very important part right here, it has to be a right triangle. Because in order for it to be a right triangle, or if it is a right triangle, it will have a hypotenuse, okay? So we're going to draw a picture really quick, and I'll try to make it neat. We're going to use a triangle right now. So let's go ahead and just do that right there, okay? So that's kind of the first, whoops, did I take a snapshot of something? Either way, we're going along, okay? We're on like 1 or 2 minutes, okay? So that's kind of the first part of the notes for today. We got to talk about the triangle first, okay? So we'll go ahead and kind of draw an arbitrary triangle, okay? Now, you may hear the word arbitrary and not know what it means. Arbitrary means like we just make it up. We just pick a number, okay? So it doesn't matter which one it is, okay? Like if I said pick a number 10, you would arbitrarily pick 7, right? Or something like that. So here's the right triangle. We'll go ahead and label this. This is the right angle right here, okay? And you got to make sure to use your signs and all that stuff very efficiently, okay? So here's what we'll do. We'll label the parts, and here's kind of what I do for students. Here's the easy one right here. If you see this little corner right here, if you imagine there's like a little arrow, that arrow is going to point to the hypotenuse, okay? So this will be the hypotenuse right here. And that's what we have. We label that as lowercase c, okay? Now, it doesn't matter for the other sides. We'll label this A, which is a leg, and then we'll label this B, which is also a leg, okay? So when you see pictures and everything like that, you're going to have to use the Pythagorean Theorem to figure that out, okay? So here's where you would pause it and copy all of that stuff down right there, okay? So we'll start solving. So we'll say solve for missing side, okay? So I'm going to make up, we'll bump this up just a little bit. Okay, I'm making these up, so they might look a little funny for right now. Okay, we'll say that this, this, and you should really get a triangle too. These triangles are really nice. Okay, so we'll say solve for missing side. We'll go this. We'll label a C. We'll label this 12 inches and 5 inches. Right. Actually, you know what? Okay, whatever. We'll do it. Okay. So here's how you would solve. Here's the best way, the most polished form. I used to go a squared plus b squared equals c squared, but I've learned to put the c squared first. So just rewrite your formula as c squared is equal to a squared plus b squared. It doesn't matter for addition because it's what we call commutative. You can flip it back and forth, so that's not going to be a problem. But all you do is you fill in everything, and the only thing you need to get right, if you get this part right, you'll get 90% of the problems correct, is that you need to figure out which one's the hypotenuse. So in this picture right here, the c value is going to be the hypotenuse. Okay, so all you do is you take that, you slide it in where the hypotenuse goes. So you have c squared, and then you have a squared plus b squared. It actually doesn't matter. We're going to use 12 and 5. Okay, so we'll go 12 squared plus 5 squared is equal to c squared right there. Okay, now what you're going to do is that we're going to solve for c, we're going to find the missing side, but you got to do order of operations. Okay, here's another common mistake that students make. PEMDAS, order of operations, says this: we do exponents before we add. Okay, so we have to do this quantity first and this quantity second. So this will be 144 plus 25. A lot of students will try to add them and go like 17 squared. That's wrong. Okay, you cannot do that. So this is going to be c squared right here, and now you can add them. This will be 169. And if you guys watch the if you watch the square, or yeah, the factoring video I made, you know that 169 is a perfect square, so c is going to be 13. And you look at your problem, it's in inches, so it's going to be 13 inches right there. Okay, so that's how you do that one. What I was going to do is show you one where you would factor and so on, and from there. Okay, so if you need to pause it right now and then copy that down. But we're going to move on and make another triangle right here. Okay, so let me make up one and kind of give you a good side. Let me see if I can make up one really quick. We'll go like this. Yeah, we'll make, this is fine. This will be an example right there. And then we'll make, I want to make a good one for you guys. Let me see. We'll make this, 20 centimeters. And then we'll make this, you know, 6 centimeters. I hope this turns out. I didn't even do these problems. And then we'll go ahead. I'll put the letter X, okay? So we're going to solve for the missing side right here, okay? So when you see this, you see it's a right triangle. We're going to use the Pythagorean Theorem right here. So we're going to find X, or the missing side, okay? Let us see. The first thing I told you to do, if you don't have to do this every single time, but at the beginning, it's going to be a little bit easier for you. Identify the hypotenuse, okay? So right there, it's going to be 20. So if you rewrite your formula and you won't have to do this every single time either, the only part we really care about messing up on is the c squared. So that's going to be 20 squared right there. Okay, so this is 20 squared. This is going to be 6 and x. So we'll go ahead and put 6 squared plus x squared. This is going to be 400. This will be 36. This will be x squared. And then for algebra, you got to do these ones. They require a little bit more algebraic work. Okay, so this is going to be, what is that? 464. Okay, let's see what the square root of this is really quick. Oh no, 364. Whoops. I tried to add them. I was doing that in my head. Okay, 4. All right, 364. So we're going to take square root 364 because we want to square root both sides. Okay, x is going to be approximately 19.08. And that picture is not to scale at all, okay? So the answer for this one would be 19.08. You circle it. So what I wanted to show you guys before was, that goes right there. So a lot of students ask me this question a lot because they want to do decimals. They don't like this right here. They don't like radical 364. Kind of the rule in math, and your teacher may be different, so this is something you got to ask your teacher. Kind of the rule in math, if you start a problem, like a real life problem, see how it says centimeters right here, centimeters and centimeters, you typically don't go to Home Depot and say, I need radical 364, you know, centimeters of fencing, or not fencing, of wire or something like that, okay? You would never say that. So kind of the rule is, and we'll do another one right after this, kind of the rule is that we don't, if it starts in centimeters or inches, you can put it in a decimal, okay? But we'll do one, and I hope it works out. We'll go, we'll do this one. All right. So that's kind of the rule right there. And I'll show you one where you kind of want to use it, leave it in a radical form. Okay, so let's go ahead. We'll go ahead and do this. This will be 6, 4, we'll go x. Okay, so that's that one. If you want to copy that down and kind of walk through it, you can do that one right there. Okay, but I'm going to bump it up because we're going to run out of time. Okay, so we'll say this is one where you would leave it in radical form. I hope it leaves in radical form. I think it is. Yeah, it's gonna. We'll show you. This is actually a good one right here. Okay. So what you do is if you want to find x, which is this right here, you're gonna identify the hypotenuse, which is 6. So we're gonna write c squared is equal to a squared plus b squared right there. The c squared value, we are worried about the c squared value. That's the only one we worry about. 6 squared right there, 4 squared right there, plus x squared. Order of operations dictates that you have to do the squares first, which is 36, 20 plus x squared. And then you're going to do your algebra skills that you guys are awesome at. Minus 20. Oh, shoot. Is this going to be? Something's wrong here. Oh, you know what? I am going too far ahead. That's incorrect right there. This would be a good one where you pause and say find the mistake, right? It should be 36. This is 16. Plus x squared. In my mind, I knew the answer was going to be 20, so I was like, okay, let's factor out 20 before I get there. It's minus 16, minus 16. So this is 20, this is x squared. Okay, so from here, you're going to square root both sides. Okay, so x is going to be radical 20. But, so let's kind of bump this up a little bit. X is going to be radical 20. So a lot of times students will be like, oh yeah, let's just put radical 20 into the calculator and, you know, the answer is going to be 4.47. Okay. Here's the thing. These are numbers, right, in math. So we are okay with leaving it in factored form. And a lot of teachers prefer it to be in radical form if there's no, if it's not a application problem. Okay. So right here we would have to factor this out. This would be 4. This would be 5. 2 radical 5 equals x right here. Okay. So this would be the answer right here. Now for me, this sucks because, use the word sucks, right? This isn't fun because when you make these right here, you know, students will do all this stuff correct, but then they'll do this part wrong, and you got to mark them wrong for this part right here, which has nothing to do with the actual like demonstration on the, you know, standard of knowing what the Pythagorean Theorem is. So for me, I typically let students just write it, x approximately 4.47. I usually just let students do that. I'll accept either answer, but a lot of teachers are sticklers for this. So make sure that you know what your teacher's asking for when you do this and which one they want you to have, okay? If you have a problem like this, where it's centimeters, you want to leave it in a decimal format. If you have a problem like this, where it's numbers, you want to leave it as a radical right there, okay? So if you enjoyed the video, please leave a like. It helps the video spread. If you also want to leave a comment or a question, please do so in the bottom. And if you're a teacher and you know if this helped you, let me know. And then subscribe as well if you want daily math lessons. But other than that, I've been Justin. I will catch you guys later. Goodbye.